All right, I picked two problems from the homework to kind of go over slow motion to help you with the problems that are going to be posted for Tuesday. And I know I went over 52 in the Google Meet, but I want to go over it again because it's similar to the alternate example on speed dating. So compare this one if you need help solving the one that's alternate example for speed dating. And I'm going to do it as a four-stepper. So let's say this was a four-step problem where we want to know, let's say the ultimate question is, can you find the probability, or what is the probability a woman scores higher than a male? So the probability a female has a score that's greater than the male. So that's going to be our ultimate question here. So to start off, kind of jump back and forth between writing and typing. So for a state plan do, the state here is going to be, what's the probability a randomly selected man or a randomly selected female has a higher SSHA score than a randomly selected man. And then in the plan, I'm just going to list all the information they gave us. I'm going to jump back to writing. So in the problem, they told us that for women at this college are female, the mean of the females is equal to 120. And the standard deviation of the females is equal to 28. And then for males, the mean score is 105, and the standard deviation of the males is 35. And then also in my plan, it didn't tell us in this problem, I kind of jumped the gun today earlier, it didn't tell us these are normal, but let's just assume they're normal. That means in my plan, if I want to know the probability a female has a higher score than a male, I can find the probability the female minus the male is greater than 0. If a female has a higher score than a male, that means if you subtract them, it's a positive number. That's why I'm picking female minus male being greater than 0. So I can find this distribution, female minus male, and I did this in my video. That means its mean is 120 minus 105. And that was 15. And I could do the standard deviation of female minus male. That's just going to be the sum of the variances. And then square root. And let me go back to my work. That ended up being 44.822. And then in the do, I'm going to find the probability that a female scores higher than a male, or the difference is greater than 0. And all I really need in my do is my curve. The mean we found was 15. This 0 on my curve is below the mean. And if it's greater, I shade to the right. And it's just a norm CDF, where your lower bound is 0, your upper bound's infinity. The mean is 15, the standard deviation is 44.822. And when you do that in 52, you get a probability of 0.631. And then my conclude, I mean, I'm not going to take the time to type this or write it, but you could kind of imagine conclude. You would say the probability that a randomly chosen female has a higher SSHA score than a randomly chosen male is 0.631, or you could say something like the probability or the 63% chance that a female is going to score higher than a male on this study habits test. All right, there's going to be a second alternate example posted on Apples. And one that's similar to that is like number 63 from last night's homework, and I kind of started off already. So this is about a swim team for the 400-meter freestyle relay. And in this table, it provides each swimmer in the relay's mean time and then standard deviation for their swim times. And assuming they're independent, so it states they're independent and they're normal, we want to know what's the probability that the total swim time is less than 220 seconds. So the state is just, what's the question asking? And this question's asking, what's the probability that this swim team's relay time is less than 220 seconds? Now in the plan, they told us each swimmer's time is normal, and they gave us the means and standard deviations in this table. Let's consider the total time. We're going to call it T. And that's going to be equal to each swimmer's time. So W, I put W for Wendy, plus Jill, plus Carmen, and plus Latrice's time. That's going to account for the total time. So now, also in my plan, the new mean time, so the mean of T is therefore the mean of W plus the mean of J plus the mean of C plus the mean of L. So I sum all those up, that's these times right here, and you get a mean time of 224.2 seconds. And the standard deviation of the total times is not the sum of the standard deviations, but the sum of the variances. So Wendy's variance plus Jill's variance, Carmen's variance, and Latrice's variance. And if you do that calculation, you get 5.56. And then the do is I want the probability that total is less than, I think it was 220 seconds. So I draw my normal curve, my mean's now in the middle, 224.2. 220 somewhere down here. And, oops, sorry, less. My wrong shading. The picture's gone. My shading should have been 220 less, should have been over here. So the probability of the total time is less than 220. Again, it's just a norm CDF now. Your lower bound now is negative infinity. Your upper bound is the 220, the right side of the shading. The mean is the 224 from the plan. The standard deviation, put it back here, was 5.56. And if you do that in the calculator, you get 0.225 as the probability that team has a 220 or beats the 220 second time, or 22.5% of the time they swim under 220 seconds. Good luck with Tuesday's problems. Just send me a remind message if you have any questions while you're working.